This video is to test an equation for symmetry. It's easy to tell if a graph is symmetrical with respect to the x-axis, y-axis, and the origin. If it is symmetrical with respect to the x-axis, then for every point xy on the graph, you can always find a point that has the same x value but the opposite y value. That means if you replace y in an equation by negative y and then get the same equation, then the equation must be symmetrical with respect to the x-axis. Okay, if a graph is symmetrical with respect to the y-axis, then for any point xy on the graph, you can always find a point, well, with the same y value but opposite x value. So that means if you replace x by negative x in an equation and then somehow simplify it to the same equation, then that equation is symmetrical with respect to the y-axis. Okay, a similar case. If your graph is symmetrical with respect to the origin, then for any point xy in the graph, you can always find a point negative x, negative y on the graph. So to test if an equation is symmetrical with respect to the origin, you need to replace x by negative x and y by negative y in the equation. And if you somehow simplify it to the same equation, then that equation is symmetrical with respect to the origin. Now let's look at some examples. Test for symmetry for the following equations. Let's start from A. Okay, so first we want to test if this equation is symmetrical with respect to the x-axis. So what do we have to do? I need to draw a graph to remind me. Okay, so if I want to test for symmetry with respect to the x-axis, I want to see if the y will become negative y, basically. So I'm going to replace y with negative y. Okay, so in the equation I have 49x squared plus, instead of y, I'm going to replace it with negative y. Let me simplify it a little bit to see if I can get the same equation back. Well, negative y squared is actually just y squared. So I did get the same equation back. So that means, yes, this equation is symmetrical with respect to the x-axis. Excuse me. So now I want to test for y-axis. Is this equation symmetrical with respect to the y-axis? I need to replace x with negative x here. Okay, so a similar case, 49. So instead of x, I'm having negative x. Y squared equals 49. Well, 49x squared plus y squared equals 49. I did get the same equation back. So that means, yes, this equation is symmetrical with respect to the y-axis also. So now let's test for origin. So now I need to replace x and y with negative x and negative y, respectively. Okay, so x and y by negative x and negative y. So I have 49 negative x squared plus negative y squared equals 49. It's pretty obvious that I will get the same equation back. So that means, yes, this equation is also symmetrical with respect to the origin. Okay, that's A. Now let's study the graph of B. Okay, so with this equation, I want to test for symmetry. First, let's test if the graph is symmetrical with respect to the x-axis. What I need to do is replace y by negative y. So here I have negative y of x cubed plus x squared minus 121x minus 121. Okay, let me change this a little bit, see if I can get the original equation back. So I'm going to multiply both sides by negative 1, so that the left side is just y. And the right side, everything will change the sign. So negative x cubed minus x squared plus 121x plus 121. It's pretty obvious this is not the same with the original equation. And here I have to say that no, it is not symmetrical with respect to the x-axis. Okay, now I want to test for the symmetry for the y-axis. Similar step, I want to replace x by negative x. So I have y equals negative x cubed plus negative x squared minus 121 times negative x minus 121. Okay, let me simplify this a little bit, see if I can get the original equation back. Negative x cubed plus x squared plus 121x minus 121. Let me compare. They're not exactly the same, nor I can turn them the same. So I have to say it is not symmetrical with respect to the y-axis also. Okay, last but not least, let me test for the origin. So to test if the graph is symmetrical with respect to the origin, I need to replace x by negative x, y by negative y. So let's see. I have negative y equals negative x cubed plus negative x squared, minus 121 negative x minus 121. Okay, let's simplify this a little bit. First of all, let me simplify the right side. Negative x cubed plus x squared plus 121x minus 121. Let me multiply both sides by negative y, or change sign on every term, basically. So x cubed minus x squared minus 121x minus 121. Is that the same equation? Let me compare to the original one. Unfortunately, that's not the same. The original one is plus x squared. What I have is minus x squared. So it's not the same one. So it's not symmetrical with respect to the origin either. Okay, so it's no, no, no. 3 no's. Now for C. Okay, let me rewrite the equation of C again over here. We want to test for symmetry. First, we want to test for symmetry with respect to the x-axis. That means I want to replace y by negative y. I have negative y equals negative 9x over x squared plus 36. Let me simplify this a little bit. Multiply negative 1 on both sides. I have, okay, so, right, so you will have y on the left side and right side. The negative 9x becomes positive 9x You may ask, do I need to change the sign at the bottom too? No, you only have to change either the top or the bottom. In this case, I'm changing the top because the top is negative already. Well, I'm getting a different equation. The original one is negative, this one is positive 9x. So I will have to say no, it's not symmetrical with respect to the x-axis. Now testing for the symmetry for the y-axis, I need to replace x by negative x. So I have y equals negative 9. Instead of x, I have negative x. Similar here, bottom negative x squared plus 36. Well, on top is positive 9x, at the bottom is x squared plus 36. If you compare this to the original equation, still not the same. So I have to say it's not symmetrical with respect to the y-axis either. Now let's test for the origin, which means you have to replace x by negative x, y by negative y. So negative y equals negative 9 times negative x over negative x squared, well, plus 36. Let's see. Let me simplify the right side first. So that's positive 9x over the bottom is x squared plus 36. Now let me multiply both sides by negative 1. So you have y equals, okay, so the negative sign I'm going to multiply to the top. Negative 9x over x squared plus 36. So yes, I did get the same equation back. That means this equation is symmetrical with respect to the origin. Okay, I hope this video is helpful, and I will see you in the next video.